All right, ladies and gentlemen. For this presentation, we're going to discuss the flip side of physical properties and physical changes, and that's chemical properties and chemical changes. Now, physical properties are sort of easy to wrap your head around because they're things that you can see, things that you can smell, things that you can touch, things that you can feel. But chemical properties are only viewable by actually altering the substance, so they sort of get blended a little bit with the idea of chemical change. So let's start with the definition. So chemical properties describe the type of reactions that substances can or cannot undergo. And the key phrase here is that when substances undergo those reactions, it changes their composition. So let's think about it this way. When you have a chemical property, it's a property that a substance has that you can't observe without changing a substance. So a physical property, like the way whether something is hard or soft. You can touch it and it's hard, or you touch it and it's soft. But with a chemical property, the minute you try to figure out if it has it, the test will change the substance. Some examples, flammability, all right? You want to see if something will burn or not. So you light it on fire. Well, the minute you light it on fire, it is no longer the substance you started with. And if it doesn't light on fire, then it doesn't have that property. You frequently see this word when discussing chemical properties, reaction. So even flammability is a reaction, but all chemical properties tend to be couched in that language of reaction or reacts with. So you can have substances that react with oxygen, you can have substances that react with acid, or substances that react with water or bases, and those are all properties. Chemical properties are basically what will you react with. Now, the thing is, the only way you can test the property is by having it do the reaction. And that's this key point down here, all right? And this is really a key idea. Once you observe a chemical property, the substance is changed. It's no longer the same. Let's talk a little bit about what that actually means. Because I think, implicitly you understand, if you want to see some physical properties of a log, you can hold it, you can touch it, you could even cut it in half and it's still a piece of wood. But when you burn it, you're seeing that it has the chemical property of flammability. But when it's done, the log is not the same thing anymore. But what's actually happening inside the log? So this is an example of a very common physical property or physical change. Okay, so here you have water molecules, and this is a water, 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 this is a water. All right? Now, when I subject that water to heat, I can boil it. I can change it from the liquid form to the gaseous form. But what you'll notice is there's still water molecules in the liquid form and still water molecules in the gaseous form. So what's happening is when things are undergoing a physical change, the compounds behave differently, but they're still the same compounds. Okay? Now, to compare that with a chemical change, this is actually something called electrolysis, which is when you break water molecules with electricity. Okay? So what happens is, here you'll notice I have those same 6 water molecules. And this time I'm giving electricity to the system. And what you'll notice is that over here I have an oxygen and 2 hydrogens. But over here I have the oxygens in pairs and the hydrogens in pairs. What's happened is that the actual substance inside, it's different. It's not the same thing anymore. And so because it's not the same thing anymore, this is a chemical change. So what you notice is that these compounds that we start with on the left on this first container are now different compounds on the right. That's the hallmark of a chemical change. And chemical changes are what occur when you observe the chemical properties of something. So, key ideas to sort of summarize this concept. Chemical changes alter the chemical structure of a substance. All right? That's a key idea, and that's what's going on in this diagram. We have one chemical structure on the left and a new chemical structure on the right. We have a compound of water on the left and diatomic molecules of hydrogen and oxygen on the right. Down here, chemical changes alter the structure of a substance, so they change it. And after a chemical changes, the original substance is not there anymore. And they're really not reversible. I mean, you can't go back and forth. Sometimes you can do it in a roundabout way. Some chemical changes just naturally go back and forth. But for the most part, they're not reversible. You can't unburn a log. Once you melt something with acid, you can't bring the substance back. Okay? And one of the things you have to understand is that this is the crux of chemistry. Chemistry is actually like understanding how chemical changes occur and why they occur and what causes them and how we can control them and how we can use them. I mean, we can change one thing into another in a way that we decide, and that's really an impressive thing. All right, so that's chemical changes and chemical properties.